Good morning, this is Mrs. Tellas. We're going to do the second part of 8.3, which is graphing quadratic functions or graphing parabolas. On the first day of chapter 1, we did y equals ax squared, and these were all on that y-axis. They didn't move from there. They all had a vertex of 0, 0. And we had some stretches and shrinks based on the A. Okay, and then on Wednesday, we did y equals ax squared plus c. Well, the plus c moved it up and down the y-axis, so the vertexes were different. And we still had stretches and shrinks because of the a in front of the x squared. So today we're going to do the whole shebang, the whole standard form, but we add this bx in here. Okay, so it's actually the bx moves the vertex off of the y-axis. And we talked about a formula, how to find the vertex and the axis of symmetry. See if we remember that. So the formula for the axis of symmetry is x equals negative b over 2a. And then the vertex, we get the x from above, from this formula up here. And then to get the y, we take the x and we plug it into the equation with the calculator. That pops out the y. I hope you remember that from yesterday. All right, so here are the steps to graphing a quadratic function. Most of these steps you already know how to do. So step 1, we're going to find the axis of symmetry, and we're going to do that by using the formula x equals negative b over 2a. Then we're going to find the vertex. We're going to take this x that we're given and plug it into the equation, and that's going to pop out the y using the calculator. Then we're going to make a table using that vertex we just came up with. And we're going to put that vertex right in the center and come up with x's by going up 1 and back 1, making this y symmetrical, and going up another and back another and making this y symmetrical. And then you're just going to plot the point you found. It should make a U shape. If it doesn't, something's wrong. All right, so let's go ahead and start this first one. So it looks like it's in standard form already. A is 1, B is negative 6, and C is 2. So if we find our axis of symmetry, this would be negative negative 6 over 2 times 1. So that ends up being 3. So the first part of my vertex is 3. So if I put the 3 in for x here and x here, that's 3 squared minus 6 times 3 plus 2. So I'm just going to type that in the calculator exactly like it says it, using the parentheses and everything. And that gives me negative 7. So my vertex is 3, negative 7. So now I put the vertex right in the center of the table. So right here, 3, negative 7. And to come up with these symmetrical points right here for the y, I go up 1 from 3, which is 4, and back 1 from 3, which is 2. These two numbers plugged into this equation will give me the same y. Then I go up another 1 from 4, which is 5, and back another 1 from 2, which is 1. And these two numbers, again, since a parabola is symmetrical, should give me the same y. So let's plug them in. So let's do the 4. So 4 squared minus 6 times 4 plus 2. Again, I'm using my calculator and those parenthesis keys. And that gives me negative 6. Both of these are negative 6 then. And I could either do the 5 or the 1. I'll go ahead and do the 5. So 25 minus 30 plus 2 gives me negative 3. So it seems to me that it's going to make a U. Let's make sure. So 3, negative 7, 4, negative 6, and 2, negative 6, 5, negative 3, and 1, negative 3. So here's my picture. Okay, the domain here is all real numbers because I could have chosen any numbers to type or to put into the up here to come up with my y. I chose these because of the symmetrical points around the vertex. And then the range, it starts at negative 7 and it's everything that goes up. So it's y is greater than or equal to negative 7. All right, let's go ahead and try number 2. So it's in standard form. A is 5, B is 10, and C is 6. So if we plug it into our line of symmetry formula to come up with our vertex, that is negative 10 over 2 times 5, which ends up as negative 1. So my vertex is negative 1 something. So I'm taking the negative 1 and I'm putting it in here in the original equation for x. So y equals 5 times negative 1 squared plus 10 times negative 1 plus 6. So if I plug that in to my calculator, I get positive 1 for y. So my vertex is negative 1, 1. So again, I make the table. And that vertex goes right in the center. So if I go up 1 from negative 1, that's 0, and up another is 1. If I go back from negative 1, that's negative 2, and back again, that's negative 3. All right, let's plug in 0. So 5 times 0 squared, and I'm putting it here in for x, plus 10 times 0 plus 6, 6. So these two are both 6. And if I do that for the positive 1, 5 times 1 plus 10 times 1 plus 6. So it looks like that's 21, which is going to be way off my graph. Yeah, it is 21. So this is 21 and this one is 2. Again, these are symmetrical. So when I go to plot negative 1, 1, actually negative 1, 1, 0, 6, negative 2, 6, 121 is going to be way up there. It doesn't even fit on my graph. And that's okay. I'm just going to estimate it up here because that's as far up as I can write. There's my picture. My domain is all real numbers. And my range is y is greater than or equal to positive 1. Because the graph starts right here and it goes up forever. Okay, which is why the range is y is greater than or equal to positive 1. All right, I want you to push pause and I want you to try number 3. All right, so if I look at the graph, it's in standard form. So a is negative 2. Notice a is negative. This one's going to open downward. B is 8, and C is positive 1. So that would be negative 8 over 2 times negative 2. 2 negatives make a positive. So x is 2. That's 4. 8 divided by 4 is 2. Okay, so my vertex is going to be 2 something. So negative 2 times 2 squared plus 8 times 2 plus 1. Let's see what that gives us. Negative 2 times 2 squared plus 8 times 2 plus 1. I get 9. So 2, 9 is my vertex. I'm going to put that, oops, that's why. I'm going to put that right in the center. So 2, 9. All right, so if I go up 1, that's 3. Up another, that's 4. Back 1 is 1, and back another is 0. Right, so let's plug these numbers in. And I did the big side last time. I think I'm going to do the small side this side, just to show you. You get the same thing. You can either do this side or this side to do your plug. You're going to get the same thing for y here and here. All right, let's start with 1. So negative 2 times 1 squared plus 8 times 1 plus 1. So let's stick that in our calculator. That gives me 7. Both of these give me 7. And if I do it for 0, that one gives me positive 1. So if I go over here and graph, 2, 9 is in the center. It's a little off the graph, but not much. 3, 7, and 1, 7, 4, 1, and 0, 1. So here's my parabola. Makes a U shape, which it's supposed to, so I know I'm right. It's a little pointy. Okay, domain is all real numbers. And range is y is less than or equal to, because it starts at 9 and goes down forever. So less than or equal to 9 is my range. How did you do? Did you get most of it right? Did you get any of it right? If you did, give yourself a pat on the back. Good job. All right, let's try this one because it doesn't have a C. Let's just make sure we understand what's going on here. So our A is 3, our B is -2, and our C is 0. Okay, there's no C, so the C is 0. Okay, just knowing that is important, I think. So negative B over 2A. So negative -2 over 2 times 3. So the two negatives make a positive. So that ends up being 1 over 3. It's a fraction. Okay, I kind of like that it's a fraction. I think that's a good thing. Okay, so let's go and put our 1/3 here. So let's type in, or let's write down 3 times 1/3 squared minus 2 times 1/3. So you're going to get some practice with that calculator button. You want to keep it a fraction and not do a decimal since that's a repeater. So 3 parenthesis 1 ABC 3 parenthesis squared minus 2 parenthesis 1 ABC 3 parenthesis. That gives me -1/3. So if I make my table, even though it's fractions, and now they're all not going to be fractions that don't have a C, but this one is. So I put my vertex in the middle, so 1/3 here and -1/3 here. Okay, so if I go up 1, that would be 1 1/3, and up another would be 2 1/3. And if I go back 1, that would be -1/3, and back another would be -1 1/3. Okay, and remember, you don't have to plug all that. You only have to do the one side, whether you choose the big or the small. I think I'm going to choose the big side. I think it will be easier because there's no negatives. All right, so let's plug. So 1 1/3. So 3 times 1 1/3 squared minus 2 times 1 1/3. That's going to take a second to type that in. So 3 parenthesis 1 ABC 1 ABC 3 parenthesis squared minus 2 parenthesis 1 ABC 1 ABC 3, and that gives me 2 2/3. So 2 2/3 here and here. Okay, let's do the same thing. This time we're going to use 2 1/3. So let's change that. And that gives me 11 2/3. 11 2/3. 11 2/3. Okay, this one's going to open up because it's got a positive A, and it needs to open up when I do it. So I'm going to go right to the 1/3 and down a little right here. And then 1 1/3, 2 2/3, -1/3 and 2 2/3 is about right here. 2 1/3 and 4, actually that's way up here, 11-ish. And 1 1/3 and 11-ish, way up here. So here's my parabola. It opens up, which I expected it to. The domain is all real numbers. And the range is y is greater than or equal to 1/3. Actually, yeah, -1/3. Because that's where it starts on the y, -1/3. Okay. All right, let's give this one a try. You have 2 of these on the homework today, so let's give this a try. So it says a volleyball is thrown into the air with an upward velocity of 72 feet per second. Its height, h, in feet after t seconds is given by the function. All right, so this is the function. This is the equation we're going to use right here. It's in standard form. How long will it take the volleyball to reach its maximum height? And what is the maximum height? And what is the range? So we've got 3 things to answer. Everything's about the vertex here. So we're going to use the formula, or actually I'm going to write the equation down first. So A is -16, B is 72, and C is 5. So we're going to plug it in our formula that we're so good at now. So negative 72 over 2 times negative 16. So 16 times 2 is 32. 72 over 32. So let's put that in our calculator. 72 ABC 32. That gives me 2 1/4, or 2.25 is my x. Okay, so I've got 2.25. That is the answer to the first question. How long will it take the volleyball to reach its maximum height? So 2.25 seconds. Okay, and then what is the maximum height is the y part of the equation. So I plug the 2.25 back in here. So negative 16 times 2.25 squared plus 72 times 2.25 plus 5. Negative 16 parenthesis 2.25 squared plus 72 times 2.25 plus 5. That gives me 86. So 86 is the answer to the second part. So the volleyball, it's going to take the volleyball 2.25 seconds, and it's going to go 86 feet high. Okay, so if I graphed that equation, it would be opening down. Okay, we'll just do a makeshift here. We'll pretend like this is 86. So, and I don't know, I do know that the vertex is 2.25. So about here, and it's going all the way up to 86. So way up here, and then it'll be going downward. Okay, now it's a volleyball. It's a person standing on the ground. So the ball starts at 0, it goes up to 86, and it comes back down to 0. Okay, so the range is from 0 up to 86, and then back down to 0. So if I want to talk about the range is between 0 and 86. So I can write a compound inequality where it's less than or equal to 86 and it's greater than or equal to 0. So this would be my range because it's between 0 feet on the ground and 86 feet in the air. All right, so I'm all finished. All right, your homework is a big ideas assignment. Okay, you can check Canvas for the exact amount. Remember, if you're doing, I would very much like for you to do this online. So to get to online, you go to the Perry Township website. And then from there, you go to the resource portal. And then hit Evaluate. And then find the Big Ideas app. Oop, I forgot the word ideas. Then click Assignments. And at that point, you should be able to submit online. Submitting online is my first choice. Now, you are going to have to write some things down on some paper, but I don't want the paper. I just want the grade submitted online. That's all I'm looking for is a completion grade. So I hope things go well. If you have questions, email me, and take care.